Welcome back everyone for another video, and in this one we're going to be taking a look at a little bit of a more challenging type of problem when it comes with area of sectors. So let's go ahead and dive right in. So we're given this kind of weird looking shape. We have a circle and we have this green part, and we're given that the sector AOB, which is of course going to be this sector right here, all of this area, with a radius of 4 and a central angle of 75 degrees. Now determine the area of the segment enclosed by the chord AB and the subtended arc. So it's kind of a really complicated way of saying what is the area of this green thing. So again, the segment enclosed by the chord AB, here's our chord, and the subtended arc is this arc that is, well, subtended by that chord. So what is this green? So you might be thinking, how can I possibly do this? Because we're not given a direct formula for being able to find out what this area is given the chords. However, what we do know is that the area of a sector is going to be whatever angle you have over 360 times pi r squared. Now, I want you to go ahead and think about what that means. Is that what it's telling us is that the entire area here can be found with this formula, which we can find right now. So let's actually go ahead and do that. So the area of the sector is going to be 75 degrees over 360 times pi 4 squared. Go ahead and put that into your calculator, and we'll get that the area is equal to 10, and let me look at my calculations, 0.4719, dot, dot, dot. I'll leave it there. If you're using Ti-Nspire, it's really nice to know how to store these values so that way you're using them in your calculations to get the most accurate answer possible. You typically don't want to round or truncate any answer before you put it in your calculator. So again, also the ANS is a really helpful tool as well. That means answer. So we're given that this entire piece of the circle here, this sector, is 10.471. Now, what I need to do is I need to think, hey, I have all of this, but I need to find just this part right here. How can I do that? Well, if you think about it, we found the area of the sector. Well, there's another shape in here that'd be really easy to find, which is this triangle right here, because we just covered that lesson of how to find the area of any triangle. If you think about it, if we have the entire area of this sector, and then we find out what the area of this is, well, if we just subtract those two, we'll be left with what is left over. So this is a problem where you find the area of the entire sector and then take out the one triangle, so that way you are left with whatever this is here. Because again, if you have the entire sector and then you take out this triangle, all that will be left is this shaded region here. So the question now becomes, what is the area of the triangle? So the area of the triangle is going to be equal to, I know it's going to be 1/2 times, let's see here, the two enclosing sides times the sine of the angle, like that. So the area of the triangle is going to go ahead and be, let me check my calculator, 274. Okay, and that'll be square centimeters. Now, again, it is, and I'll see, I need to put a little dot, dot, dot here. It's a shame that you can cut out the finer tuning here. There we go. Okay. So again, if you're able to store these values in your calculator, and that way you can subtract them from each other in their full, perhaps irrational form, that would be really, really beneficial, because again, you don't want to round or truncate too early when you're doing the process, or the calculations, I should say. So again, if we have the area of the entire sector, we're going to subtract out the triangle, and we'll be left with what it is right here. So you'll find that the green area here is going to be equal to 10.4719 dot, 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 and we're going to subtract from that 7.7274 dot, 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 and we will find that the enclosed area is going to be, to three significant figures, 2.74 square centimeters. And there we have it. So again, while the answer might not look obvious because we're not given a formula to directly find the area of this enclosed area, if we use what we have gone over previously, is that if we can find the entire area of the sector, take out that one triangle, well, what's left over? There we go. This specific area that we're looking for. And so again, we're using some formulas that we have used in the past. all together to solve new types of problems. I hope that helped, and I'll see you all in the next one.